The next topic of discussion is going to be the process of encapsulation and de-encapsulation coupled together with ARP, or the ARP process. ARP stands for Address Resolution Protocol. Actually, before I move on to there, I should mention that there is a site online where you can go practice your subnetting, and the site is called subnettingquestions.com. Great site. You go on it, it asks you a question, and then you say show answer, it'll show you the answer, and then you do the next question, and so on and so forth. So the site is subnettingquestions.com. So before we move on to the de-encapsulation and ARP process, I wanted to show you what the protocol data unit called a packet at layer 3 looks like. Well, a packet pretty much looks like a frame, except the address fields, instead of a MAC address, you have an IP address. And again, the first field is the destination IP address field. The second field is the source IP address field. Then you have the data field and the frame check sequence. The frame check sequence houses the cyclic redundancy check, and it works exactly the same way as it does with the frame. Now on to encapsulation, de-encapsulation, and ARP. Host 1 and host 2 are residing on the same LAN. Sometimes I get asked the question, is host 1 and host 2, are they connected to a switch? Is there a switch in the middle? The answer is most definitely yes. But however, here I have drawn a logical diagram, not a physical diagram. In a logical diagram, you exclude switches. So yes, there is a layer 2 switch here in the middle, but I have excluded that from this diagram. Host 1's IP address is 10.10.10.1, and host 2's IP address is 10.10.10.2. Host 1 wants to ping host 2. At this point, I have to talk about what ping is. Ping is basically a testing utility. And ping works with the protocol Internet Control Messaging Protocol, or ICMP. Ping has two parts, an echo and an echo reply. So basically, if host 1 wants to ping host 2, on host 1 from the command prompt, you would type ping 10.10.10.2. And host 1 would send out an echo ICMP message down to host 2, and host 2 will read that message and send back an echo reply, or ICMP echo reply. Having said that, let's get back to the diagram. Host 1 wants to ping host 2. So does host 1 know its own IP address? Yes. Does host 1 know its host 2's IP address? Yes. So host 1 creates a packet with the source IP 10.10.10.1 and destination IP 10.10.10.2. Now let's assume host 1's, once again, MAC address is A. And of course, as always, this is not 48 bits, it's only 16 bits. But we're going to assume it's A. And we're going to pretend this is 48 bits. And host 2's MAC address is B. Host 1 has already created a packet with source IP 10.10.10.1 and destination IP 10.10.10.2. Next, to transmit over the local data link. Remember, even though there is a switch here in the middle, both host 1 and host 2 are on one data link. A switch is one data link by default. Host 1 needs to create an Ethernet frame, because you use layer 2 for transmission over the local data link. So host 1 needs to create an Ethernet frame to send that packet over to host 2. Host 1 needs host 2's MAC address to create the frame. Host 1 already knows its own MAC address is AAAA, but host 1 does not know host 2's MAC address, which is BBBB. So at this point, host 1 generates an address resolution protocol request, which is a broadcast. So host 1 generates an ARP request requesting for the MAC address of the device with IP 10.10.10.2. So host 1 is actually saying, whoever has IP 10.10.10.2, please send me your MAC address. Now, this ARP request is a broadcast. It is actually sent to the destination address 255.255.255.255, which is the all networks, all subnets broadcast address. Everybody's going to hear it. If there were other hosts here, they would hear it too. But I'm trying to keep it simple to explain this concept. Host 1 generates an ARP request, which is a broadcast, asking for the MAC address of the device with the IP 10.10.10.2. And host 1 transmits that broadcast. Host 2 receives that broadcast and looks inside and finds that its own IP is 10.10.10.2. So host 2 replies to the ARP broadcast, and the ARP reply is actually a unicast back to the IP address of host 1. So the ARP reply will be sent to 10.10.10.1. Host 2 replies with its own MAC address in the ARP reply, which is BBBB. At this point, host 1 has the MAC address of host 2. Host 1 has its own MAC address, and host 1 also has the MAC address of host 2. This is the function of ARP. ARP basically resolves IP addresses to their relevant MAC addresses and then stores it in a table. So this process will only happen once on host 1. Once host 1 has host 2's MAC address resolved, once it has a binding in the table that says IP 10.10.10.2 has a MAC BBBB, it won't need to go through this ARP process a second time. Next, host 1 encapsulates the original ICMP packet and puts it inside of the Ethernet frame that it created. The Ethernet frame that it created has a source MAC of AAAA and destination MAC of BBBB. So the frame would look something like this. So the destination MAC would be B, 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 B. The source MAC would be A, 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 A. And then you have the frame check sequence housing the CRC. As I said, host 1 will encapsulate the original ICMP packet inside of the frame and put it inside the data portion of the frame. So the packet will actually be sitting inside of the frame. The destination IP would be 10.10.10.2. The source IP would be 10.10.10.1. And then you have the data and the frame check sequence housing the CRC. The act of encapsulation means I take the layer 3 packet and I put it in the data portion of the frame, which is what we see here. This is the data portion of the frame. Host 1 will then transmit the frame over to host 2. Host 2 will receive the frame and match the destination MAC address field in the frame with its own MAC. Once it matches, host 2 will discover or know that this frame belongs to me. It was meant for me. Host 2 at this moment will de-encapsulate the frame and extract the original packet. Basically discard the frame and extract the original packet. Then host 2 will match the destination IP address in the packet with its own IP address, which is .2 here and .2 here. Since it matches, host 2 will send back the ICMP echo reply. That concludes the ARP encapsulation, de-encapsulation portion of this lecture. Next, we will learn how to configure IP addresses on our routers, and then we will see this process in action on our lab.